let's see here. We're just going to push through the rest of these videos in order to get to the machine learning section. We're not going to do the exercises until we get to the final capstone project. I don't think we're going to do both the capstone projects. But we'll see. We'll see if I enjoy them and have fun. But for right now, I'm just going to push through these last, what are we at, 2 or 3 modules? 1, 2, 3. 3 modules. Should take less than an hour. And yeah, just watch them. And then practice it when it's actually time to do the thing. So let's get into it.
Hello everyone, and welcome to the Pandas built-in data visualization lecture. In this lecture, we're going to go over Pandas' own built-in capabilities that are actually built off of Matplotlib, but they allow you to call data visualizations directly off a data frame. Let's go ahead and jump to the Jupyter Notebook.
Ooh, hold on. What time is it?
All right, here I am at the Jupyter Notebook server.
Alright, so apparently the audio capture works now. I don't know why it wasn't working before. That's good though. It's not gonna pick up the shakiness of this. I have lasagna in the oven. It's supposed to take 45 minutes to get done. I don't remember what time I put that in. I'm gonna assume it's been like maybe 10 minutes. Oh shoot. I'm selling. It's okay.
Server, quick note, data visualizations directly off a data frame. Hello everyone, and welcome to the Pandas built-in data visualization lecture. In this lecture, we're going to go over Pandas' own built-in capabilities that are actually built off of Matplotlib, but they allow you to call data visualizations directly off a data frame. Let's go ahead and jump to the Jupyter Notebook. All right, here I am at the Jupyter Notebook server. Quick note, you should be opening this Jupyter Notebook under Python for Data Visualization, the Pandas built-in data viz folder. And the reason for that is there's a couple of CSV files here called df1, 2, and 3. And these are CSV files that we're going to be working with to actually show the capabilities of Pandas built-in data visualization. The lecture notebook is right here. It says Pandas built-in data visualization, and then you also have an exercise which we'll go over later. I'm going to go ahead and open a new notebook here and go ahead and get started. All right, here I am at this notebook, and I'm going to go ahead and say import numpy as np. I'm going to import pandas as pd, and then I'm also going to specify matplotlib inline so I can see the data visualizations inside of this actual notebook. And then the CSV files that we're going to upload are df one, so I'm going to say pd read CSV, pass in df1, and for df1 I'm also going to specify that the index be the first column at index 0. So now if I look at df1, I can see that the index is actually a time series, and that's going to be important when we actually visualize that out. And then for a non-time series index, I'm going to go ahead and say pd read CSV, and then pass in just df2. Then if I take a look at df2's head, it's very similar, except this is just random data and it has a sequential index. All right, Let me go ahead and just show you a quick example of what you can do with these sort of data frames and these columns. Imagine we wanted to get a histogram of all the values in the A column for df1. Well, pandas can actually do that directly. We can just call df1 and then call hist off of this, and it will actually automatically start creating a histogram. And note that it's actually calling matplotlib under the hood. And then you can begin to add in matplotlib arguments, or even Seaborn style arguments, like the number of bins you want in this histogram. Okay, now something to note is this style actually isn't very good looking in my opinion. So what you can do in order to fix that is if you come up to the top or really anywhere in the notebook, go ahead and say import Seaborn as SNS. And once that's imported, if you start running these cells again, it will look like a Seaborn plot. It'll look a little nicer. So that's something I like to do. And you can actually set Seaborn styles, and the pandas calls will look like them. Pandas has several plot types built into it, and what we're going to do is just briefly go and show examples of how to create these plots. Pretty much all the plots can be done through a command off of the data frame. And you can basically do this with two methods. You can call the data frame itself, or call a column off the data frame. Let's go ahead and just do a column now. And you can call plot, and then under the argument of plot, specify kind. And there's a list in your notebook, and we're going to go throughout this list. And then you specify the keyword of the kind. So if I wanted a histogram, I could also create it this way. And then here you can add in histogram arguments, such as the number of bins you want. So that's one method of creating, for example, a histogram off of a data frame column. You call it dot plot and then call kind. All right, the other way you can call a plot using pandas is instead of specifying kind equals hist, you can actually call hist directly off of plot. So you can say dot plot and then dot hist, and this will also create the plot. This is the method we're going to be using throughout the rest of this lecture. So we're going to either grab the entire data frame or the column, call dot plot, and then call dot whatever the plot type we want. Let's go ahead and just go through all the plot types and check them out. So let's go ahead and work with df2, which is the non-time series. So as an example, this has a normal index. And one plot you can do is an area plot. So you can go ahead and specify plot.area, and this is essentially just going to show an area plot. And what you can also do is specify alpha as an argument here if you want some more transparency. So you can say alpha is equal to 0.4, and this shows some transparency here. And this is just showing the area of the values. You can essentially just think of this as a normal line plot, except the area underneath it has been filled in with some sort of color. All right, that's an area plot. And again, just very easy to call off the data frame. Let's go ahead and take a look at bar plots. So you can say, pass in your data frame, df2 plot, and then bar, and this will automatically create a bar plot. And what this does is it just takes the index value basically as a category. So in this case, your index should be categorical. Our data frame is actually small enough so this makes sense. So if we take a look at the data frame, it only has 0 through 9, so this works. A typical data frame with a sequential index, you probably wouldn't want to do this. But if it's a categorical index, then as a category, it'll just list the values per each column. And you can actually also create this to be stacked by passing in stacked equals true. And you'll get a plot that looks like this. Basically the exact same thing, except it's stacking the values. Now personally, I would actually recommend that you use Seaborn for these types of plots, but if you're just doing some very quick analysis, this sort of thing is going to work for you, just calling it off of pandas. Now let's call histogram, just to clarify what it looks like again. So I'm going to call, let's say df1, a dot plot dot hist. We've seen this before, and here's our histogram, and you can specify the number of bins you want. So if we want a larger number of bins, in order to get a little more clarity. As far as pandas plots go, and doing stuff that's built into pandas, histograms are probably the one I use the most. You can also do line plots, which is another common one that I like to use for pandas. For example, if we check out df1, remember that's our time series index. Let's imagine that we wanted to plot the data of one of these time series. We can go ahead and just say df1 plot, and you can call line. This is just going to create a line plot. And for the line plot, you have to specify the x and the y. So in this case, I want the x to be my actual index. So I can say df1.index, and I want my y to be one of these columns. And you pass in the column as a string. So I'm going to go ahead and just pass in, let's say, b. And if I just run this, I get a plot that looks something like this, essentially just a line plot. So you can imagine if this was stock information and you wanted to plot it out versus time, you can get something that looks like this. And since this is all built off of matplotlib, you can begin adding matplotlib arguments, such as the fig size you want. So let's say we want something much wider. You can do something like this. Or let's say we wanted to adjust the line width. Well, you can just do LW, just like we saw for matplotlib, and set the line width to something a little skinnier. You can add in markers, all these other matplotlib commands. So everything you've learned about matplotlib can be applicable to these data frame plots. Now let's go ahead and check out scatter plots. So let's say I have df1, I can say plot.scatter, and you're going to I have to specify an X and a Y. So for this, let's just go ahead and pass in strings of column names. So A and B. And this will create a nice looking scatter plot for us. Something else you can do is actually set the color based off another column. So for instance, you can say C, the color is going to be equal off column C. So if I just run that, it gets me a black and white. So if I take a look at df1, just to clarify what we're doing here, data frame 1, we have a value for A and B, and we have a value for C. So essentially we're showing now 3 levels of information, a 3-dimensional plot, if you will, since we have A versus B, and then a third argument C displayed by color. And you can actually pass in C map as an argument and pass in your own color map. So for instance, cool, warm, which you've seen before. And now you're showing 3 levels of information, A versus B, where they stand, and then the color value for C. Sometimes people don't like to show things by color, but prefer to show them by size. You can actually do that as well. Instead of passing C as an argument here, you'll just go ahead and pass in S. And for S, you'll go ahead and pass in a data frame column. So for this, you have to actually pass in the data frame column itself. And you probably, if you just do this, the points will be too small. And what you can do is multiply this by some sort of factor. So now you can see the points are A versus B, and the size indicates how large their C value was relative to each other. All right, this is the kind of thing where you probably wouldn't remember this all off the top of your head. You would go back to the Jupyter Notebook that I've assembled for you and use that as a reference, or check out the documentation. Let's go ahead and move on to box plots. Again, I really like Seaborn for box plots, but if you just want a quick analysis of a box plot, Pandas can do that for you as well. So you just pass in your whole data frame, call plot, call box, and here you can see a box plot that's basically automatically done for you per column. So it just takes every column as a category and then plots the distributions for you as a box plot. All right, for bivariate data, you can do a hexagonal bin plot, which you've actually seen before with with Seaborn. But let me go ahead and make a new data frame for this to actually show up correctly. So I'm going to say PD data frame. I'm going to pass in some random data, rand n, and I'm going to have this be 1000 by, let's say, 2. And then I'm going to pass in the columns to be just A and B. And if we take a look at our data frame, it looks something like this. Just some random data, A for B. I just wanted some more random points here. And what I can do, since this is bivariate, or 2 variables here, A and B, I can say plot.hexbin, pass in X is equal to A, pass in Y is equal to B. And if you just do this, you will get a hex plot. Now this is essentially like a scatter plot, except it's the hexagonal bins. Right now the bin size is really quite small. So to change that, we can say grid size is equal to 25. And this will enlarge the size of the hexagons. And essentially the hexagons get darker as there's more points inside of them. And you can also change the color mapping here. You can say CMap is equal to something else. So for instance, if we wanted cool warm to be our color mapping, you could do that as well. And then finally, we can do kernel density estimation plots. So if for some reason you don't just want a histogram, but you want a kernel density estimation, you can call your data frame or a column off your data frame and then just say plot KDE, and it will create this kernel density estimation plot for you. And you can do the same thing with density, which is another call you can make. So you can say density, and that will be the same thing. So if you want a density or kernel density estimation plot, those will be the same thing. And you can actually do this off the entire data frame as well. You don't have to do it just off of one column. If you wanted to compare the kernel density estimation plot of all the columns in your data frame. All right, that's it. Hopefully you can see why this method of plotting directly off of pandas is a lot easier than calling full matplotlib. And it balances ease of use with control over the figure. You should note though, if you really want to start customizing your figure, you should be falling back to Seaborn or matplotlib. These sort of commands are really just for a quick analysis of your data. And you'll probably just go to the notebook, quickly reference the kind of plot you want to create, and then call it off the data frame or call it off the column of the data frame. As far as how we're going to use this throughout the course, really the only times we're probably going to use this is just with a line plot or a histogram to call it very quickly. For more advanced statistical plots, such as box plots or bar plots, I would really recommend going with Seaborn. Okay, I hope you found this useful, and I will see you at the next lecture where we're going to describe the quick exercise for you to practice what we just learned here. Thanks everyone, and I'll see you at the next lecture.
Yeah, that's basically all it. Okay.
Hello everyone, and welcome to the Plotly and Cufflinks lecture. In this lecture, we're going to learn a bit of the background behind Plotly and Cufflinks, which allow us to create interactive visualizations. Plotly is an interactive visualization library that's open source, and Cufflinks connects this library with Pandas. And that way we're going to be able to create interactive visualizations directly off our data frame. However, before we actually explore these libraries, we're going to need to install them. You'll need to
Why is this taking a little bit too long? It's questionable. Shouldn't be. Yeah. Already satisfied. Sure. Okay. Where are we at? Cufflinks. Pip install cufflinks.
use pip to install these libraries either at your command line or at your terminal, and you can write pip install plotly and pip install cufflinks. This should still work even if you're using the Anaconda distribution. These two libraries just aren't available on the Conda install at this time. So go ahead and use pip install plotly and pip install cufflinks at your command line or terminal in order to get these libraries. Now let's go ahead and get a quick tour of the official website before in the next lecture we actually show you how to use these libraries. I'm going to go ahead and jump to Plotly's official website now. Alright, here I am at the Plotly website. It's at plot.ly. And you can check out the website. There's a lot of information on it. And a quick note, Plotly is also a company, but they make money by hosting your visualizations and hosting your dashboards. If you want to keep everything local or host it yourself, the library that operates on all these features is open source and free. So don't worry, you won't have to pay something to use Plotly.
It's kind of in depth.
And Plotly is compatible with a variety of tools such as R, MATLAB, Excel, and JavaScript, but we're going to focus on using it with Python. If you go ahead and click on this Python link, you'll get a link to a Getting Started page with Python. And it'll show you how to get started, and interestingly, it'll have a link to Pandas. And that's what we're going to be focusing on, using Plotly with Pandas. And in order to use Plotly with Pandas, you need to install Plotly, as said here in the instructions, but you're also, later on, going to have to install cufflinks. And cufflinks is the library that connects Plotly with Pandas. And I'm going to go ahead and go to the GitHub page for cufflinks. And this is the GitHub page for cufflinks. And cufflinks basically, it's a productivity tool that allows you to quickly call plots just as you would with Pandas. For instance, a dataframe.plot method, but instead you'll actually create an interactive visualization using Plotly.
Really?
And a quick disclaimer, I'm actually a contributor to this library myself, and you can actually see my merged branch right here at JM Portilla. But anyways, there's pretty nice tutorials here under cufflinks, and we're going to go through some of these topics and show you how to actually use cufflinks effectively in order to create really nice looking interactive visualizations. And here's just an example of one, UK swap rates, and you can see that this is a 3D surface, and this is done directly off of a data frame.
All right, yeah, I'm going to have to do this one.
This. But you can turn them off and on too.
This is kind of tough. This is actually legit. Wait. Okay. This makes sense. Okay, I'll just do it. Yeah, it's empty. Ooh, this one should be fun.
Where we actually show how we can program using these libraries to create interactive data visualizations. Let's go ahead and jump straight to a Jupyter Notebook to get started. All right, here I am at the Jupyter Notebook. I'm going to go ahead and do a couple of imports and then some setup in order for this all to work. I'm going to say import pandas as PD, import numpy as NP, and then I'm going to go
tweaking.
go ahead and say from Plotly import underscore underscore version underscore underscore. And I'm going to go ahead and say print version.
Oh, sure. Yeah, 5. Whoa, there's been a lot of versions. He's doing 1.1.2.
I notice here I get 1.12.
1.12. 5.24 is kind of different. How old is this? How old is this video? Hold on, give me a second. Just gonna look at this real quick. Overview. 5 years old, May 2020. This is freaking ancient. It's better than nothing. Alright, let's go. Yeah, it's free.
Here, I'm already on 1.12. That means I'm good. If you have a version that's 1.8 or below, you'll need to upgrade Plotly. If you just install Plotly, you should be totally fine on this. Next, I'm going to go ahead and say import cufflinks as CF. And then finally, I'm going to import some libraries from plotly.offline. So Plotly, as a company, can support your online and can host your online data visualizations. But since we're going to be using this as an open source library and we're going to be using it offline, we'll need to do some imports from plotly.offline in order for that to work. I'm going to go ahead and
no more droning cufflinks. Cufflinks. Let me see. Check the terminal. Did I do the right one? Cool. module named cufflinks? I'm gonna restart the whole thing. Oop. Because it's installed. It's there. It's on the computer. Why can't you find it? There we go. What the fuck? Are we serious? Can I do this? And it works. how do we hide this? Can we, like, yeah, just shrink that thing up. All right.
And import, download, plotly underscore plotly.js, and you can just type D and then tab, and it should autocomplete for you. I'm also going to say init. I'm just doing tab to autocomplete, init underscore notebook underscore mode, and then also plot and iplot. Run those. And then we're going to do a couple more commands. In order to have everything work in the notebook, just call init underscore notebook underscore mode and pass in connected equals true. And this is going to connect the JavaScript to your notebook, because Plotly essentially just connects Pandas and Python to an interactive JavaScript library. And this is going to allow your notebook to access those
Too fast. Let me slow this down. Tweaking right now.
visualizations. And then finally, we're going to say cf go offline as a method and close parentheses and run this. And this will allow us to use cufflinks offline. All right, quite a few steps here to make sure everything works out, but hopefully you're able to follow those. Let's go ahead and now get some data and create it. I'm going to go ahead and say df is equal to pd.dataframe.
Okay, well,
I'm going offline.
Why is this important?
Because Plotly is autocomplete. And you can just type D and then tab, and it should autocomplete for you. I'm also going to say init source library, and we're going to be using it offline. We'll need to do some imports from plotly.offline in order for that to work. I'm going to go ahead and import, download plotly underscore plotly.js, and you can just type D and then tab, and it should autocomplete for you. I'm also going to say init. I'm just doing tab to autocomplete, init underscore notebook underscore mode, and then also plot and iplot. Run those, and then we're going to do a couple more commands. In order to have everything work in the notebook, just call init underscore notebook underscore mode and pass in connected equals true. And this is going to connect the JavaScript to your notebook, because Plotly essentially just connects Pandas and Python to an interactive JavaScript library. And this is going to allow your notebook to access those visualizations. And then finally, we're going to say cf go offline as a method and close parentheses and run this. And this will allow us to use cufflinks offline. All right, quite a few steps here to make sure everything works out, but hopefully you're able to follow those. Let's go ahead and now get some data and create it. I'm going to go ahead and say df is equal to pd.dataframe. I'm going to say np.random.randn, so normal distribution, and just pass in 100 by 4. So 100 rows, 4 columns, and I'm going to go ahead and say columns is equal to a, b, c, d as a string dot split, and that way we get a list of the columns a, b, c, and d. And if I check df just ahead of it, here I have my data frame. And I'm going to go ahead and create one more data frame called df2 pd.dataframe, and I'll use a dictionary for this.
Okay, let me check my lasagna. Okay, needs another 5 minutes.
I'm going to say category is a column.
Excuse me. So we're making a new data frame, okay, with category or with the column. Category being one of them.
And then the values are just going to be A, B, and C, or just any 3 strings you want. And then the other column is going to be values, and this is just going to be a string of some random values. Let's go ahead and just say 32, 43, 50.
Cool. Basic.
And this is going to be used later for like a bar plot style. All right, now let's just go over how to use cufflinks in iPlot. It's actually extremely straightforward. If we take a look at our data frame, we have A, B, C, and D here. If I just call .plot off of this data frame, Pandas will plot something with matplotlib. And if I actually want to see that plot, I can say matplotlib inline. And then if I run this again, let me go and just cut this and put it up top here. Whoops. There we go. And I'm going to come back down here and run this plot one more time. And here I see the line plot that Pandas would have made automatically using matplotlib. I can just change this to iPlot, and we're going to see almost a little bit of magic happen. That plot has now been converted to a Plotly interactive image, and here I can kind of scroll along, and it'll actually tell me the values at that particular index point. So it's the exact same plot, it's a line plot, but now it's interactive. I can zoom in, check out values, I can double click to zoom back out, and I also have tools here. I can save and edit the plot.
That's actually crazy. So it automatically does it for you. That's so neat. Convenient.
Plot. I can download the plot as a PNG file, so if I just want a static image, I can pan. So if I wanted to, I could pan around. I could zoom in, zoom out, reset the axes, choose the hover, so closest on hover or compare data on hover. By default, you probably usually want to use compare data, and then I can even click on and off certain columns to view. So if I just want to view A and C, here I can view A and C. All right, hopefully you can already tell this is an extremely powerful tool because basically you just had to add one letter, iPlot, and now suddenly you look like an amazing interactive data visualization programmer when your secret was just adding iPlot and using cufflinks and Plotly. All right, so that's the most basic example of cufflinks and iPlot, and let's go ahead and explore now the various types of plots we can do. We can do many types like scatter, bar, box, ratio, heat maps, and more. So what we're going to do is just go through them and show you how to use iPlot to create other plot types that are not just line plots like this one. Let's start. to create other plot types that are not just line plots like this one. Let's start off by showing you how to do a scatter plot. I'm going to go ahead and say df.iplot. And then in order to switch the type of plot, you specify kind equals, and then for scatter, the string is scatter. Now for scatter plot, you need to specify the x and y axes. You can go ahead and specify this by the column name. Let's go ahead and show a scatter of A column versus B column. And if we just run this, you'll see something funny pops up. You get something like this. And by default, Plotly is going to try to make a line to connect all these points. So what you have to do is specify mode and pass in the string markers. And then you'll actually get some markers here. And you can check out the markers, and then you can actually compare the A and B columns. You can zoom in and check out information.
Okay, let me check that lasagna again. right, we are back.
On each of these points. All right,
Cool.
so that's how you can use a scatter plot using df.iplot. Pass in x and y arguments as the column names, specify kind is equal to scatter, and then pass in the mode equals markers. You can also do other things, such as pass in arguments for size. If you want these points to be bigger, you can go ahead and specify a larger size, and it'll go ahead and make those points larger.
No.
Now let's move on to a bar plot. For bar plots, you can say df.iplot, and say kind, pass in the string bar, and then you specify x, and we're going to go ahead and switch to df2 since that's a better fit for this plot. Just a reminder, df2 has a categorical column and a numerical column, meaning for a bar plot, you want the x to be the categorical column. To make this obvious, I'm just going to say x is equal to the category column, and then y is going to be equal to the values column. And if we go ahead and check that out, now we have a bar plot where if I zoom out a little bit, I can see the value for each of these categories. So C is 50, B is 43, and A was 32. All right, and you can zoom in if you want, but that may not be too helpful for a particular bar plot. Let me go ahead and continue on. Now, as we know, your data is not always going to be conveniently placed, such as df2 with a category and values column. But what you can do is call group by or an aggregate function on your data to actually get it into some sort of form where it makes sense to use a bar plot using iplot. Let me go ahead and show you what I mean by that. If we take a look at our original df, we can see that we have A, B, C, and D. Now, we wouldn't be able to call bar plot off of this, otherwise we'll just get a bunch of bars. And I'll show you what I mean by that. If we just said kind is equal bar, you'll get a bunch of bars for every single data point. That's not exactly what you want. You would need to do some sort of aggregate function on top of this. For instance, let's say you wanted to count the instances for each column. And here we have a bar plot for each instance, which in this case is just 100 since they're all evenly distributed. But you can do other things such as take the sum of each column, and now we have a bar plot showing the sum of each column. All right, pretty interesting stuff, but keep in mind that this bar plot with iplot becomes really powerful when you call some sort of aggregate function or a group by function on your data frame. More likely your data frame is not going to be in this kind of nice formatting. Okay, that's a bar plot. Let's discuss box plots. Now, box plots, your data can be something that looks like this. Box plots will automatically do that sort of aggregation for the distribution. And you just do this by specifying kind is equal to box, and here it will automatically make a box plot for each of the columns, and you can turn columns off or on either by passing them here with df or just by switching them on and off here with plotly. For instance, if I only wanted to see A and C, I can just click on A and C, and I can click on B and D as well and see what I want. And it'll give you information on the quartiles here for the box, which is quite convenient. Now let's talk about a 3D surface plot. In order to really talk about the 3D surface plot, I'm going to make a new data frame. We'll say df3 is equal to pd.dataframe, and we'll go ahead and say x is a column, and we'll just say 1, 2, 3, 4, 5. We'll specify y as a column with the values 10, 20, 30, 20, 10, so it goes up and then down. And then we'll specify z is a column, and let's go ahead and specify this to be 500, 400, 300, 200, 100. Okay, so I have my data frame. Let's take a look at it. And this is basically 3 dimensions of values, or 3 variables. We can use a surface plot if we wanted to create a 3-dimensional surface plot of these 3 variables. You can say df3.iplot and specify the kind to be a surface plot. And this will create...
Oh, hold on. This is the one that we want to do. df3. This seems freaking cool. Can't wait for us to actually get into freaking like for loops, while loops, just different types of loops. You know, as we start to do this, create plots and do all this interesting stuff. We're just going to use the same values that he gave us. Okay. Ooh, okay, what happened? All arrays must be of the same length. Are they not? Are they not, sir? 1, 2, 3, 4, 5. Okay. df3 dot iplot kind is going to be surface. Wow, it's a little underwhelming, but that's still cool. Okay, let's pan around. It's only 2-dimensional. Okay. Zoom, rotate, turn to a rotation. Here we go. Oh, interesting. Cool.
Create a surface plot of what we have here. So you can see we have a surface plot. Now, let me show you another example of a surface plot by kind of changing these values around. Instead of saying 100 through 500, I'm going to say 5, 4, 3, 2, 1. And now let's plot this, and we can see now we have kind of this peak outline. And we can actually change the color scales here in case we don't like this rainbow. Color scale. And we can actually change, and now let's plot this 100. I'm going to say 5, 4, 3, 2, 1.
Oh. Pretty cool, pretty wild. Yeah, it's pretty neat.
And now let's plot this, and we can see now we have kind of this peak outline. And we can actually change the color scales here in case we don't like this rainbow color scale. We can say something like color scale, and say RD for red, yellow for white, YL for yellow, and BU for blue. And you can check the Plotly documentation for all the color scale codes. They don't exactly match up with the Matplotlib color maps, so keep that in mind. And here we have a really nice surface plot directly made off our data frame. We can rotate it and play around with it in order to get all the information out of it. All right, that was a 3D surface. And finally, I'm going to talk about a couple more plots. A very basic one that you'll probably find yourself doing is a histogram. You can say df, call a single column, and then say iplot, kind is equal to hist, and you'll get a histogram. And you can actually specify the number of bins with another argument. For example, if you want 25 bins, you can specify that and get more bins. Let me go ahead and make this more obvious by specifying a lot of bins. Okay, and here we have more bins. Now, there weren't that many data points, so keep that in mind. If you go ahead and pass in the entire data frame, let's just call it df.iplot kind equals hist, you will get a overlapping histogram of all columns, meaning you can compare the histograms of columns, and you can turn them on and off to compare them to each other. Now, these are randomly normally distributed, so you're kind of overlapping a lot. And finally, I'm going to talk about a couple more plots here in case we don't like this rainbow color scale. We can say something like color scale, and say RD for red, yellow for white, YL for yellow, and BU for blue. And you can check the Plotly documentation for all the colors by specifying a lot of bins. Okay, and here we have more bins. Now, there weren't that many data points, so keep that in mind. If you go ahead and pass in the entire data frame, let's just call it df.iplot kind equals hist, you will get a overlapping histogram of all columns, meaning you can compare the histograms of columns, and you can turn them on and off to compare them to each other. Now, these are randomly normally distributed, so they're kind of overlapping each other, which makes sense given the way we created this. But you can turn them off and on to view histograms as you please for all the columns in the data frame. So it's up to you whether you want to just pass in one column or pass in the whole data frame and then switch them on and off. Next one I want to show you is a spread. Spread type visualizations are used a lot for stock data to compare two stocks. I'm going to go ahead and just do them with our random values here. Later on in the financial data capstone project, we'll actually see some more technical analysis plots. But if I just say these two columns, A and B, off my data frame, I can say iplot kind is equal to spread, and we'll get a plot and then a subplot. I'll get my line plot, which shows them against each other, and then I'll get my spread plot, which shows the spread of them against each other. So for instance, if we go ahead and zoom in here on the 20, we can zoom in here. Let's see where it corresponds to 20. We'll notice the spread is negative 0.38 between them, and here we can verify that as a result. So negative 0.38 minus 0.18 will take us to 0.56 about there. So you can go ahead and compare these results. And this is essentially really useful for stock data to see the spread between two stocks. We have two more plot types to show you. The next one is a bubble plot. And a bubble plot is very similar to a scatter plot, except that it will change size of the points based off of another variable. So if I say kind is equal to bubble, I'll specify x and y just like I did for a scatter plot. And then I will specify the size of the bubbles based off another column. Let's go ahead and just choose C. And here now I have a scatter plot, except the size of the points is based off another column value. And you see these kind of plots a lot for things like world GDP in comparison to population and maybe happiness factor, etc. So these are quite common plots, especially for things like United Nations reports. Right. So that's the bubble plot. And then finally, we'll get to the scatter matrix. The scatter matrix plot is essentially very similar to Seaborn's pair plot. It just creates a scatter matrix of all the columns it can. So you say df.scatter_matrix. You may need to make sure all your columns are numerical in order for this to work, but it's just a scatter matrix, and you can kind of zoom in on each plot individually. Keep in mind, if you have a lot of points here, this will take a while to load and may be very slow as far as zooming in and out. So use this with care on very large data sets, otherwise you may crash your Python kernel. Okay, that's it for the basic plot types that we're going to go over in this lecture. If you want more information and some more details about the documentation, I would recommend actually going to the GitHub page, and that's available just by searching GitHub and cufflinks. It should take you to this page. It's hosted by this user, Santos Jorge/cufflinks, and I've contributed to it, as you've seen before. And you can check out right here these cufflinks tutorial links where you have a chart gallery. It'll let you know what colors are available, offline, pandas like, and plotly. There's a lot of really good information here. So for instance, if we go ahead and say pandas like, so if you're not interested in financial analysis at all, don't worry about this, but you can check out a couple of the functions here and a couple of the types you can do. It allows you to do things such as moving averages or correlation between plots or stocks, etc. We'll explore some of the... Okay. Thanks, everyone. I hope you enjoyed learning about Plotly and cufflinks. It's a really powerful tool, and the good news is you don't have to adjust your knowledge that much for it. You essentially just add an I and remember what kind of plot you want to pass. Okay. Thanks, everyone, and I'll see you at the next lecture. Hello, everyone, and welcome to an Introduction to Geographical Plotting lecture. In this lecture, we're going to briefly describe our approach to geographical plotting for this course. By its nature, geographical plotting is usually very challenging due to the various formats the data can come in, and a lot of times you have to find a specific library to work with for your specific data source. For this course, we're going to focus on using Plotly for plotting since we've worked with it in the past, but I should also note that Matplotlib also has a base map extension which allows for you to create static geographical plots using Matplotlib. We're going to focus on Plotly due to its interactive visualization capabilities. Alright, so let's go ahead and get started with geographical plotting by learning how to use Plotly to create these choropleth plots. Thanks, everyone, and I'll see you at the next lecture. information either on a global scale or on a nationwide scale. Hello everyone, and welcome to the choropleth maps lecture. In this lecture, we're going to go over how to use Python and Plotly to create choropleth maps, which will allow us to plot out information either on a global scale or on a nationwide scale. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. This Jupyter Notebook is called choropleth maps, and you can find it under Python for data visualization under the geographical plotting folder. And you should
Oh, jeez. Where's my mouse? Oh, you can do it like that. Okay. I said cough links. Crazy. Excuse me. What? About this. Alright, we're good to go here. Add a new cell below. Pip install. Forgot what it was. Was it charts? Chart Studio. Okay. Should be good to go, maybe. Possibly. It might have worked.
Just start a new notebook there or work inside of this notebook in order to access the CSV data we're going to be working with. Again, all the code we're going to be typing up is a reference here, and also you should note that there's references as far as explanations. Choropleth plots can be really difficult at first, especially with the syntax used for Plotly, so you'll always want to keep this notebook as a reference for things. And what we're going to do is just go out and explain the code in this notebook, see some simple examples at first, using just nationwide scale plots, then we're going to see some real data, do a larger plot on nationwide scale, and then we're going to go ahead and see the world scale, so we can actually plot onto countries. All right, let's go ahead and start a new Jupyter notebook. All right, here I am at a Jupyter notebook. I'm going to go ahead.
Okay. Let's go get some food. Hopefully this isn't cold. Hold on. Food break.